the record. Okay. So your screen is shared, right? You are seeing the screen. Okay. So it started raining here. Wow.
Here also.
Hmm?
Here also.
One second. I'll just switch on the light. I'll quickly. So there also it's raining. Wow. Here also it's raining. Um, so as I said, the definition on page 20. So the definition on page 20, that's what is the first thing required. Okay. So you'll see that a binary operation, so some label they have to give. That's why what they say is a star on a set A, okay, is a function. It's defined in such a way that it is a function and you have from A to A. So that's even before we say it has to be A cross A. See, this is A cross A to A. So we denote this when we are doing this. Earlier what we got used to was when we say, for example, addition of two numbers. We say 2 plus 3 or 3 plus 4. We were putting the symbol in between. Okay. So actually this is operation, an addition operation. But then with this new definition, we will say star. That means the symbol is put in the beginning and we say A comma B. This is a notation. Okay. So then what it means is we are doing A star B. Okay. We denote star A comma B. That means A star B. This star can be any operation. It can be addition or it can be subtraction. It can be first addition and then subtraction. Okay, it can be any combination, multiplication or division alone or square root or any combination also. Okay, so that means operations can be extended, and that is why instead of giving one symbol for everything, here they put a star and they define that operation. Okay, so these are the binary operations, and what we'll talk here is how do we make a table, something called operation table. How do we make an operation table and what is a binary operation? Okay, so first of all, when do we call something as a binary operation? Okay, so what do we mean by binary operation? If we have some operation done on A and B, okay, so if we get that, for example, you are trying to say divided by. So that means if I say star AB, that means A divided by B. So it should be a function. In order for that to be an operation, it must be a function. So A by B is not a function, and if it is not a function, it is not an operation. How do we know something is not a function? Yeah. How do we know something is not a function? So we know that vertical line test and things like that. If there is a vertical line test failing, then obviously then it is not a function. So the definition of the function is what we will be talking about. Okay. So next, if it has to be a binary operation, the result also should be belonging to the set. Okay. So set of numbers, whatever we are actually taking in, for example, 1 plus 2, and we are saying on the natural numbers. Okay. I'll give an example for this. Okay. So I am defining this operation over n natural numbers. That means A belongs to natural numbers, B belongs to natural numbers, and we want to see what happens to A star B, whether A star B is binary or not. So we call this binary operation if the result also belongs to n. That is the important thing. So now let us take So many natural numbers are there. 1, 2, 3, 4, and so on. These are all the natural numbers. Okay. So let's say a equal to 1, b equal to 2, any other natural number. Okay. So if I have a star b, which means 1 plus 2, that's equal to 3. So 3 belongs to n. Therefore, the star in our case, star is a binary operation. I'll take the same thing. I will define the star now as a divided by. And I will take again over natural numbers only. So I want to see now.
Okay.
I take 1, 2, 3, 4, and so on. So only when a equal to b, then a by b equal to 1, and that belongs to n. But when a is not equal to b, for example, a is equal to 1, b is equal to 2. So a by b will give me 1 by 2. 1 by 2 does not belong to n because it's not natural number. Therefore, this operation is not binary operation. Understood, right? You get 1 mark
Yes, sir.
questions on this. So that is why that the labels, natural numbers, what is a rational number set, and integers, all that concept must be clear. Positive integers, negative integers, real numbers, rational numbers, natural numbers, all that definition is important thing. So we had the first definition, definition 10, that's on page 20. So next definition is 11. These things having what? An operation, if operation is binary, then we have to check whether it is commutative and whether it is associative. Okay, the property is commutative, and then you'll have associative. Okay, and finally whether it has identity. It has an identity, whether it has an identity or not. Okay, so finding that identity, once it has an identity, whether there is a inverse possible, inverse operation possible. So these are all the properties, and this is where you'll have many 2 marks questions coming. This is where the 2 marks questions start. This is the 1 mark. Got it? So I'll tell you now what is commutative. Commutative is obviously if a star b equal to b star a, then it is commutative. Associative, you pick up 3 things for associative. Say let a belongs to whatever is that relation. Okay, it can be R or it can be whatever. Okay, and all belong to same set. It can be rational numbers or real numbers or natural numbers. Then a star b star c equals to a star b star c. Whether you associated these things first or a and b first, you still get the same result. Then we call it as a associative. The operation is associative. So the operation is commutative or associative. Then comes the identity. Identity is the simplest but often get confused. Okay. So what do you mean by identity? So you have that operation. So you have some operation, like for example, I have 1, 2, 3, 4, 5, and so on. Okay. So I would like to do A star B, and if I get in such a way that the answer is B, then A is called identity. Also this A must be belonging to whatever is that. It can be R or N or whatever. So in this case, can you tell me which one can be the identity? One can be identity, or two can be identity, or three can be identity. Which one you think identity? And if say the star is for example is a multiplication. Star is multiplication. Then you can pick up for example 1 star 2 is 2. You pick up 1 star 3, you get 3. You get 2 star 3, that's equal to 6. Okay, so 2 is definitely not identity. 1 is a identity. So 1 is called identity. So in this case, the operations are important. If I replace this multiplication, and I say the star is addition, for example. So we will be asking, can you find additive identity? Can you find additive identity? That means you did the operation like A plus B, and you should get a B. So this is possible only if A equal to 0, but 0 doesn't belong to n if it is n, natural numbers. Therefore, no additive identity for natural numbers over addition. For natural numbers, multiplicative identity exists. Got it, right? We will be seeing those examples in the further as we go forward. So that is about commutative, associative, and has identity. The last one is inverse. So you have to see that the important things are whatever we are taking this entire thing, the set is also important. Okay. So what is the next one? Next one is a inverse. That means whether inverse for each element exists. So what does it mean? If A star B equal to whatever is identity, then A and B are inverse to each other. Okay, let us take now real numbers, for example, to say real numbers. That means you can have everything minus 200, so minus 140, whatever, you can have minus half, 0, half, 1, 2, 3, 4, like that. Now I pick up two numbers. Let's say A is equal to 2, B is equal to 1 or 1 by 2. And I want to say this operation is multiplication. So then I have A star B, 2 star half. Okay? So I get 1. Obviously 1 is the, because 1 into A equal to A, 1 into B equal to B, and therefore 1 is identity. So therefore 2 and half both are inverse to each other. Inverse to each other. Okay, so that's a kind of example for inverse. So these are the definitions. Again, you will get as a 1 mark questions, whatever I covered from 10, 11, 12, 13, or 14. So the operation is called invertible, whether the invertibility is possible or not, and if it is possible, which of them are inverse to each other. Okay, so coming back to the exercise now, 1.4. So the first question, determine whether or not each of the definition of star given below gives a binary operation. In the event the star is not a binary operation, tell me the justification. That's the first question. So the first one is on Z plus. So it is on Z plus. So this is nothing but positive integers. Positive integers. So positive integers 0 is not included. Okay, you have 1, 2, 3, 4, 5, and so on. These are the positive integers. He is defining the operation A star B. So star is defined in such a way that A star B equal to A minus B. So you have to pick up two numbers, and you have to subtract the second one from the first. That's what it is. Okay. So now you can pick any of these things. So how you have to say, if A minus B is greater than or equal to 0, or let's suppose not equal to, let's suppose greater than. If A minus B is greater than 0, then the result is a positive integer. So that will happen only if A is greater than B. That will happen only if A is greater than B. If A is less than B, the result will be negative. So therefore, not a binary operation. We have to state like this, and then you have to give an example. So let A is equal to 2, B is equal to 3. A minus B, or A star B, we have tried A star B, equal to A minus B, that's equal to 2 minus 3, this is minus 1. Minus 1 does not belong to Z plus. Therefore, not binary operation. Okay. So
Sure.
we have given the first one. Second one, A star B is AB. So can you try the second one? You just give me the say whether it's a binary or not. Tell me the justification. I'll write down the steps for you.
Should I say, sir, if it's binary?
When will I say binary? Oh yeah, you should say whether it's a binary or not. So you should perform that operation on the numbers. What is the operation here? Multiplication, right? So Z plus basically contains all that 1, 2, 3 onwards.
Yes, sir.
So you pick up any two. You pick up A and you pick up B. Multiply them. If the result is in Z plus, then it is a binary operation.
Yes, sir.
It is binary?
Yes, sir, it's binary.
Okay, it's binary. So it's binary because all for all A, B being positive, their product is also positive. Product means multiplication. Okay, so that implies that A star B, okay, is a binary operation. We can pick up an example that A is equal to 10, B is equal to 1. So A star B equal to AB is equal to 10 belongs to Z plus. That's it. Okay. So
Yes, sir.
third one, it is on R. That means on real numbers. And he's saying A star B is AB square. This means you pick up AB, you pick up 2 AB. So A multiplied by square of the second one. Okay, that is nothing but B. Okay, so that's what AB square meaning.
Yes, sir.
So when you do this, whether the result will always be in R or not.
Uh, will be on R.
It will be odd because everything is a real number except that square root of -1, which is not real. All others are real numbers only. So you multiply, for example, a equal to root 2, b is equal to another one, maybe root 5. So you multiply a, b squared, you will get 2, no, root 2 into b squared is 5. 5 root 2 is a real number. Okay, so therefore it's a binary. Then the next one, fourth one. It is defined on z plus. Again, positive integers. So here he is asking a star b is defined as mod a minus b. Okay. So remember when we did the first one, the first question, there also we got a minus b. But then that operation was not binary.
Yes, sir.
Now, even a is less than b gives a minus b as negative. Mod a minus b is always positive.
Yes, sir.
So that implies that the result of operation belongs to z plus, therefore binary. So fifth one. Here a star b is a. Wow, this is a funny operation, right? It says a star b. So whatever you multiply, you don't care what is the next one, but you are picking up a only. That is not the answer. So, but still you are picking up anything from 1, 2, 3, 4, 5, whatever. Here a star b, meaning you pick up 1 star 2, the answer is 1. Okay, if it is a and b are 1 and 2. If a is equal to 2, b is equal to 3. So here 2 star 3 equal to 2 only. But still 1 belongs to z plus, 2 belongs to z plus. Therefore, a binary operation.
Yes, sir.
These are all 1 mark only. Okay, you won't get more than that. The next question, second question, is kind of a little bit all the testing of the properties, whatever the properties we have, and that's what we are testing. Okay, second question. So for each of this operation defined below, first thing, determine whether it is a binary. If it is a binary, then commutative or associative. Okay, he's not talking about any other, commutative or associative. Test all these things. Okay, so second question, and that's first one. This is on Z. That means all integers. All integers. Okay, and operation is a minus b. So star is defined as a star b equal to a minus b. So first thing is whether a minus b will give us a binary operation or not. So do you think it's binary or not?
Binary, sir.
It's binary. Good. Let's suppose it's binary. Now what he wants to do, he wants to say whether it is a commutative or associative. So definitely A minus B is not equal to B minus A, right? If
Yes, sir.
if A is not equal to B, then A minus B is not equal to B minus B. Therefore, not commutative. Then the associative. That means we picked up three A, B, C belonging to Z. Okay. So we want to write down A star, B star, C. We want to check this, whether this is equal to A star B star C. So we'll first pick this B star C, meaning B minus C. So A star B minus C, meaning A minus B minus C. That's equal to A minus B plus C. This is LHS. RHS will be, so we first A star B equal to A minus B. So A star B star C, meaning A minus B minus C. This is RHS. So LHS is not equal to RHS. Why? A minus B plus C is not equal to A minus B minus C, because this is plus C, this is minus C, right? Therefore, not associated. See, I'm not using numbers, okay? You are not supposed to use the numbers. In the worst case, like you can't prove this way, then don't leave the question in exam. Try to do at least with the numbers. But full marks will be given if you do without substituting doing any example numbers. All right. Now,
Sir.
second question. I would like you to be interactive and tell me whether that's Q. Q means rational numbers. Rational number set. Okay. So A star B is defined as AB plus 1. This is how they define. That means whatever are the two numbers, you take it, you multiply them and add 1. So the first question, is it binary? That's the first question.
So should I answer this?
Yeah. Yes, you should answer.
It is binary.
Binary. Why do you think so? Okay, so I could not hear, maybe internet problem. Because you consider any rational number like 2 by 5 multiplied by another, say 3 by 7 plus 1, you still get a rational number. Okay, that's why it's binary. Next one, whether it's a commutative. Second one is whether it's a commutative. So for every A belonging to Q and B belonging to Q, A star B, which is equal to AB plus 1, okay, can be written as BA plus 1, which means B star A. Therefore, commutative. Next one,
Yes, sir.
associative. So let A belongs to Q, B also belongs to Q, C also belongs to Q. So B star C will do first, then I'll get BC plus 1. Then I do A star B star C. That means A multiplied by entire thing BC plus 1 plus 1. So that's equal to ABC plus A plus 1. Now let's say A star B, that's equal to AB plus 1. A star B star C equal to AB plus 1 multiplied by C plus 1. That's equal to ABC plus C plus 1. So that implies that A star B star C is not equal to A star B star C because these two are not equal. Okay? Therefore, not associated. Okay?
Okay, sir.
Can you try and tell me third one?
Okay, sir.
Hmm. You don't have to send it by WhatsApp. You just say the answer. That's it. Okay?
And sir.
So done. Tell me, is it?
So it's both commutative and associative.
Okay. So binary, obviously, right? It's binary also.
Yes, sir.
Okay. Good. So do you want steps or you have the steps? Answer is correct. Do you want me to write the steps?
Sir, I check if it's right. If it's right.
Okay. So I will write that. Okay. It's correct. Then, so we are looking at first one for every A belonging to Q, V belonging to Q, A star B equal to AB by 2 is also a rational number. Therefore, AB by 2 belongs to Q, or A star B belongs to Q, and therefore it's binary. Next one, AB by 2 can be written as BA by 2. So that implies A star B equal to B star A, and therefore it is commutative. And third one, let A, B, C belong to Q. So we'll do A star B star C. That's equal to A star BC by 2. So this is equal to the first one and second one. That means A multiplied by BC by 2 divided by 2. That's equal to ABC by 4. Now let's look at A star B star C equal to AB by 2 star C. So AB by 2 multiplied by C divided by 2. That's equal to ABC by 4. Therefore, associative. So did similarly in a similar way?
Yes, sir.
Okay, good. So the fourth one. So this is on Z plus. Oh, you didn't ask me, like I had not many students, only very few students in last year, PUC, second PUC. Um, Actually, one girl from CMR, she got 98 in maths,
Okay.
98 out of 100. She has been taking tuition from me from her 9th standard onwards, 9th, 10th, 11th, and 12th. Okay. So she was in CBSE, 9th and 10th. Then 11th and 12th, she has taken PUC. So she got 98. Actually, after the exam, she told me only one mistake she has done, and that mistake will take 2 marks out, and nothing, no other marks she will lose. Exactly like that only she was actually crying for doing that mistake. Otherwise, she would have got 100.
Okay.
Okay. So, of course, it's a student's effort, not mine. Actually, she has put a lot of practice and confidence. Okay. Fourth one, Z plus is A star B is 2 to the power of AB. A star B is defined as 2 to the power of AB. So look at positive. He said it's a positive. Okay. So now we have to check whether it's first thing is a binary operation or not. Okay. So let's say A belong to Z plus and B belong to Z plus. So then A star B is 2 to the power of AB is 2 to the power of some positive number. If 2 to the power of positive number, so the positive numbers can be 2 to the power of 1, 2 to the power of 2, whatever. So this is definitely greater than or equal to 2, this operation. So 2, this 2 actually is whatever 2 you get belongs to Z plus. Therefore, binary operation. Then we are trying commutative or not. 2 to the power of AB is equal to 2 to the power of BA. That implies that A star B equals to B star A. Therefore, it's a commutative. Then the next one, say A, B, C belongs to Z plus. All are positive integers. So we have to look at first A star B star C equal to A star 2 to the power of BC. Now this is one number, first number, this is the second number. So the result is 2 to the power of A into 2 to the power of BC. Okay. So this is what is
Sir.
the answer. Now for the other one, A star B star C would be A star B is 2 to the power of AB, and then you are doing star C. That means 2 to the power of AB multiplied by C into C. These two are not equal. Okay.
Yes,
Therefore,
sir.
A star B star C is not equal to A star B star C. Therefore, not associated. So we are done with the 2 to the power of AB also. Then the fifth question is A star B is defined as A to the power of B. On Z plus, A star B is defined as A to the power of B. Okay. So for every A belongs to Z plus, B belongs to Z plus, A to the power of B, okay, is always a positive integer. Therefore, A to the power of B belongs to Z plus. That implies it's a binary operation. Then the next one, whether it's a commutative or not. So A to the power of B is not equal to B to the power of A, except when A equal to B. In all other cases, it's not equal to. That means 2 to the power of, see, whenever it is not, we can show the example. 2 cube is not equal to 3 square. Therefore, it is not commutative. Now we have to see whether it is a associative or not. Okay. So, first thing, do you think it is binary or not binary? This one, this question. I think I just want to discuss for some time and then we'll go to whether it is binary
It's
also or
not
not.
binary.
I was waiting for that. Tell me in which case it's not binary. Tell me when it is not binary. It is just a discussion. I mean, maybe you are wrong also. It could be binary. But tell me, why do you think it's not binary?
I don't know, sir.
Don't know. But then how? Uh, so just thought it's okay. I'm going back. I'm referring the textbook. Okay. 1.4. We are doing fifth one, right? Is
Yes,
neither
sir.
commutative nor associative. That's all the answer given. Okay. Which means it's binary. Definitely binary. Okay.
Okay, sir.
Not commutative. Now let us check for is let's check for A star B star C. That's equal to first B star C. That means it is B to the power of C. Then A to the power of B to the power of C. And let's look at A star B star C. That's equal to A to the power of B star C. That's equal to A to the power of B to the power of C. So both are equal, right? Therefore, associative. Okay.
Yes, sir.
So last question, sixth one. So it is on R. That means real numbers except minus 1. So all real numbers except minus 1 on R minus. This is how they write it. That means minus 1 is not included for the values. So A star B is defined as A divided by B plus 1. So first thing, we have to check whether it's a binary or not. So for any A belonging to R, B belonging to R and A is not equal to B, or even A is equal to B also, okay, or A equal to B. In whichever case, A star B equal to A divided by B plus 1, okay, is a rational number, isn't it? You will have A is equal to 2, B is equal to 3. So then you'll have 2 by 3 plus 1, which is 2 by 4. Half. It's a rational number. All rational numbers belong to real numbers, isn't it? Therefore, it's a binary operation. So the result is back into the real numbers. For any value you take it, you still get the rational number. Rational number is a real number. Okay. Then comes we have to see whether it's a commutative or not. So A by B plus 1 is definitely not equal to B by A plus 1. So that implies not commutative. It's not commutative. Okay. In the third case, let A, B, C belongs to R, which is minus, that's minus 4. So A star B star C, first this one, equal to A star B divided by C plus 1, that's equal to first one A divided by B divided by C plus 1 plus 1. That's equal to A into C plus 1, the C plus 1 will go of B plus C plus 1. A star B star C equal to A by B plus 1 star C. That's equal to A by B plus 1 divided by B plus 1, so C plus 1. So that's equal to A divided by B plus 1 into C plus 1. So that's equal to A divided by BC plus B plus C. So definitely the top one, whatever we have got, A into C plus 1 divided by B plus C plus 1 is not equal to A divided by BC plus B plus C. That implies and not associated. Okay. So now we have to look at the question number 3. Consider the binary operation. He gives a symbol, caret symbol, on the set 1, 2, 3, 4, 5, defined by A caret B equal to minimum of AB. Write the operation table for this operation. Remember, I told you one time that how do we write an operation table? Okay. So oh, it's adding. I'm not seeing this. Okay, anyway. So this is the one. So third one, operation table will be generally here you will put the operation, what operation you are doing. Here in all these cells, you will write down the result of the operation. So you will see the next page. He has given table 1.2 is an operation table. Okay. So you can have A this side and B this side, not a problem. So he has to, you have to take from the set 1, 2, 3, 4, 5 only. So this can be 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. We don't need this stuff. I'll erase that. So first one, he said the operation is defined as minimum of AB. So between 1 and 1, if I take 1, comma 1, what is the minimum of 1 and 1? 1 only, right? So that is this. So whether this 1 belongs to 1, 2, 3, 4, 5? Yes. Of course, it's a binary. We don't need to write down because you just wanted only the table. Then the second one is we are taking 1 and 2. Which is the minimum of 1 and 2? 1. So this is 1. Minimum of 1 and 3? 1. Minimum of 1 and 4? 1. Minimum of 1 and 5? 1. Minimum of 2 and 1? 1. Minimum of 2 and 2 is 2. Minimum of 2 and 3 is 2. Is 2. 2. Minimum of 3 and 1? 1. So is all this is 1. Minimum of 3 and 2 is 2. This is 2. This is 2. This is 3. Then you will have all threes here. And this one is 3. Then this is 4. This is 4. So here this is 3 and this is 4 and this is 4. So we filled up this table and that's what the answer is. This is what is called the operation table. Okay. Then fourth question, we have to use the table what is given in the 1 star 2, that 1.2. So he is asking compute 2 star 3's. He's asking the next question is fourth one. I'm not writing the table here. I'm just now looking at how do we compute 2 star 3 star 4. So first one, you go from the left side. You have got 1, 2, 3, 4, 5 down, right? The under the star. So from there, when you do 2 star 3, 2 and 3, you'll get 1. 2 star 3 is 1. So at under the star, you go to the second one. So take right. Okay. So under the 3, you will see 1. Column number 3, 1, 2, 3, third column, second row, right? So you get 1. Then pick this 1. That means you are going to the first row. So then you are doing 1 star 4. That means first row, fourth column. You will get answer 1. Therefore, 2 star 3 star 4 equal to 1. So next one he is asking 2 star 3 star 4. That's what he's asking. So look at the table 3 star 4, third row, fourth column. So that's equal to 2 star 1. So I replaced this entire thing with a 1. Okay. So second row, first column, 2 star 1 is 1. Okay. Then second question is asking for 2. Is it commutative? First thing is commutative. This what we have done is nothing to do with that. So we need to check whether 2 star 3 equal to 3 star 2. Okay. So second row, third column, 2 star 3 is given as 1. Then that is 1 here. So 3 star 2, third row, second column is also 1. Therefore, commutative. Then third one, third question. Compute 2 star 3 star 4. So 2 star 3 star 4 star 5. So 2 star 3 we have already done, which is 1 star. 4 star 5, fourth row, fifth column is 1. So you are looking at 1 star 1, which is 1. That's the answer. So fourth question is done. Fifth question, sixth question. Here we will have to use a little bit of, justifying the answer and all. Fifth question, star B star dash is a binary operation on the set 1, 2, 3, 4, 5, defined in such a way that A star dash B is a HC of A and B. So now he's asking, is this operation same as the operation defined in the exercise 4 above? Justify your answer. To do that, we just have to make an operation table. So fifth question, make operation table. Operation table. So you also do parallelly, I will also do, okay, and let's compare. Right. Do you remember HCF or you don't remember HCF?
I remember a bit, sir.
Okay. So now let's, you pick up any two numbers, give me two numbers, I'll try to give you the HCF of. You give me any two numbers, not necessarily from the table.
2 and 10,
10 and
11.
10 and 11. Okay. So for these two, the common factors is only 1. Therefore, HCF is 1.
Okay.
Give me another two numbers.
14 and 27.
27. Okay. Again, so when you write 14, this is 2 into 7, and 27, this is 3 into 3 into 3. So obviously, if you put 1, and 1 is the common factor, and that's the highest common factor. Therefore, HCF is 1 again. Okay. So let's look at HCF of 2, 4, 6 is 2. Okay. Highest common factor is 2 in this case. So like that we do. So now I am making the table for this. You also make a table. Okay. In this case, you are looking at 1, 2, 3, 4, 5. You have to take 1, 2, 3, 4, 5 only. Which means you make a table 1, 2, 3, 4, 5, 1, 2, 3, 4, and then one more 5. So you have done 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here I write HCF of 1 and 1, it's 1. HCF of 1 and 2, it's 1. HCF 1 and 3, 1, 1, 1. HCF 2 and 1, 1. HCF 2 and 2 is 1. HCF 2 and 3 is 1. HCF 2 and 4 is 2. HCF 2 and 5 is 1. Can you complete the remaining? And then we will check.
Yes, sir. I have to complete the full thing, sir.
Yeah, yeah. You have to fill for 3, 4, 5, no? Remaining.
It will be 1, 1, 1,
So 1, 1, 1.
3.
So anyway, let's look at this. This I think I made mistake probably. Okay. 3 and
and 1 only.
1 only. Yeah. Next.
Am I wrong?
Yeah, I think this is to be 3. So for me also this should be 2. because we are looking for 2 and 2. Factors for 2 are 2 into 1. Factors for 2 are again 2 into 1. Highest is 2, right? That's why it's 2. Similarly, this is 3. Okay.
This one.
Then this one is not 3. So for
Yes, sir.
3, it's a 3 into 1. For 4, it's 4 into 1. The highest common is only 1. Therefore 1. So
Okay.
1, 1, 1, 3, 1, 1. Okay. Fourth one. Now try for 4.
1.
1.
2.
Good.
Then 1 only.
Hmm.
2. 2, I think, sir.
4 and 4. It's like 3 and 3.
3, 4 then.
Hmm.
This will be 1 now.
Correct.
1, 1, also 1,
Hmm.
1, 5.
Yeah. Now look at the table. So the table in the textbook, right, is exactly same.
Sir.
We compare each and everything. It's exactly same. So he's asking, is that operation same as this? So the answer we should write yes. Star dash is star of excess 4. Okay. Justify your answer because every element is same. That is a justification.
Yes, sir.
So now we are going to the question number 6. Star is an operation on n. N is a natural numbers. Given by A star B is the LCM of A and B. So we are trying to find the LCM. That's all. So the first one is 5 star 7. That means LCM of 5 and 7. Do you know how much is LCM of 5 and 7?
Sir.
How much? Just multiply them. Okay. 35.
Yes, sir.
Okay. Second one, LCM of 20 star 16. Now don't multiply them. Okay. LCM of 20 and 16. So this is what you do, right? 16, 20. This is how we will be doing. So 2 8s are 2 10s are. Then 2 4s are 5s are. Right? So 5 4s are 20, 22s are 40, 42s are 80. That's LCM.
Sir.
So second one, is it commutative? Is asking, is it commutative? So what we need to test is LCM of 5 7 same as LCM of 7 5? Yes. Okay. So that's why yes. Then it is it associative? This is an interesting question. So you'll have to pick 3 numbers. So he has taken 5 and 7. Let us take 5, 7 and 20. Okay. So what is that associative meaning? So we are looking at 5 star 7 star 20 is the same as 5 star 7 star 20. So that means 5 star LCM of 7 and 20 is 140. So LCM of 5 and 140, if you take 5 and 140 like that, then we will say 5 ones are 5 twos are 10 and 48 are. So 28 fives are 140. Right? So LCM of 5 and 140 is 140. Now on this side, LCM of 5 and 7 is 35. So now we have to look at 35 and 20 LCM. So 20, 35. So again 5 fours are 5 sevens are. So it is 28 into 5, which is 140. Therefore, it is associative. Both are same, right? That's why it's associative.
Yes, sir.
Find the identity of star in N. So now he is asking find the identity. So that's the fourth question, fifth question. Identity of the star, identity of the operation in N. That means you have to take two, like A star B should be equal to B. That means LCM of A and B equal to B.
Okay, sir.
Yes, it is possible. If A equal to 1, then you take anything 1 star 5 equal to 5. LCM of 1 and 5 is 5. 1 star 200 equal to 200. So you're getting the same element, right? So since 1 star B equal to B, okay, for every B belonging to the natural numbers, 1 is the identity. Understood? So
Yes, sir.
which elements of n are invertible for the operation? So now look at the fifth one. Which elements are invertible? This means you have to take A star B, okay, for A belonging to n, B belonging to n. So such that A star B equal to identity. What's identity in our case? A star B equal to 1. So now you have to pick LCM of two numbers should be equal to 1. What does it mean? That means A must be 1, B also must be 1. Okay, so only if that is the number 1 is invertible. Got it, right? That means you take 1 and you take LCM of that, you will get 1. So you did the LCM operation, you got the identity. So that's why this is a kind of a trick question. Okay. So sixth is done. Then the next one is star defined on the set 1, 2, 3, 4, 5 by A star B equal to LCM of A and B. Is it a binary operation? Justify your answer. So now he has taken 1, 2, 3, 4, 5 only. Very simple. Easy question. We don't need to be drawing bigger thing for this. No need to make a table. Seventh question. It's 1, 2, 3, 4, 5. So you pick any of them. For example, say LCM of 2 and 3. That's what the 2 star 3 here. 2 stars 3, LCM of 2 and 3 is actually 6. But 6 does not belong to 1, 2, 3, 4, 5. Right? Therefore, not a binary operation. You pick up any other thing also. Like you take 3, 4, that will be 12. It's not part of 1, 2, 3, 4, 5. So, eighth question. Star B operation on n defined by A star B is HCF of A and B, which is the same as our question 5. Only difference is he has taken all natural numbers. So is star commutative? We have done that, right? So is it commutative? Yes, it is commutative. Was it associative? Yes, it is associative. Does there exist identity for this binary operation? Yeah. That means you take HCF of any two, you should get that one only. Meaning, I'm doing only that part of the question. Okay. Eighth question is their identity. So identity is when you are taken A star B and you will get B. Okay. So A is called identity. But when do you get this? So you take anything, for example, HCF of 1 and 3 is 1. So definitely 1 star 3 is not 3. Is 1 star 3 is 1 here. Okay, so the question they are asking is, does there that means there exists an identity for this binary operation. Okay, so you are not having any identity, therefore no identity exists.
Yes, sir.
No identity exists because you are always taking the higher one, right? Not the lower one. Okay, so you are taken 1 and 3, it is HCF of 1 and 3 is 1. Okay, so it is not 3.
Yes, sir.
Okay, that's why no identity exists. Ninth question, start be a binary operation on the set Q of rational numbers as follows. Which of that operations are commutative and which of them are associative? Okay, I think we still have 9, 10, 11, 9, 10, 11, 3 big questions and 2 short questions. We will try as much as possible. Okay, so will you be able to understand if I explain to you A star B is A minus B? He said it's a binary operation. So he wants to check whether commutative or associative. So B minus A minus B, if whatever is a number you get, definitely is a rational number. Therefore, B minus A is also a rational number. Agree? Don't agree?
Yeah.
Right? B minus A can also be a rational number, right? So, associative, also associative. Okay? Both commutative as well as associative. Second one, A squared plus B squared is commutative. Whether it is associative or not, I will write down for that. Okay. Only the tough questions I am doing. Okay. Easy ones I am not doing. So the second one, 9, 2. We are now looking at A star B star C equal to A star. So B star C meaning B squared plus C squared. Now A star B, this one meaning, so this square plus B square plus C square whole square. Whereas A star B star C equal to A squared plus B squared star C squared. That's equal to A squared plus B squared whole squared plus C squared. Sorry, this is not C squared, this is C. So the first one, A square plus B square plus C square whole square, is not equal to A square plus B square whole square plus C square, because you'll get C to the power of 4 here, you won't get C to the power of 4 here, right? Therefore, not associative. Then go to the third one, A plus AB. A plus AB. So this is A star B. If it is B star A, then that will be B plus BA. So A plus AB is not equal to B plus BA. Therefore, not commutative. So whether it is associative or not. Okay.
Yes, sir.
So whether it is associative or not. So then we are doing A star, B star, C. 1 second, I'll respond to this message. So now A star, B star, C equal to, so the first one, that means A plus the first one into, sorry, we have to do for the B star C first, right? So this is not correct. So A star B plus BC, that's equal to, again you have to write the first element A plus second element A into B plus BC. So you will get A plus AB plus ABC. And now we say A star B star C equal to, first one is A plus AB star C. So first element plus first element and the second element. So that will give A plus AB plus AC plus ABC. So definitely this and this are not equal. So A star B star C is not equal to A star B star C. Therefore, not associated.
Yes, sir.
Understood, right? So we have the next one, A minus B whole squared. Fourth one is A minus B whole squared. That's A star B. So A star B equal to B star A, since A minus B whole squared equal to B minus A whole squared. Therefore, commutative. Now let's say A, B, C are there. So A star B star C equal to A star B minus C whole squared. Then whatever you get, this entire thing, A star A minus B minus C whole squared whole squared. A star B star C equal to A minus B whole squared star C. That's equal to A minus B whole squared minus C whole squared. So A minus B minus C whole square is not equal to A minus B whole square minus C whole square. Definitely they are not equal. Okay. Why? Because you will get C to the power of 4 here. Here you won't get C to the power of 4. Therefore, not associated. Next one is AB by 4. So fifth one is A star B is AB by 4. Definitely commutative because AB by 4 equals to BA by 4. Therefore, commutative.
Yes, sir.
Then A star B star C equals to, it is very similar to what we have done in the second question. So it's A star BC by 4. That's equal to, so AB, so ABC by 4 divided by 4. That's equal to ABC by 16. So A star B star C equal to AB by 4 star C. That's equal to ABC by 4 divided by 4. of ABC by 60. Therefore, associated. So the last one. The last one I mean is last in the ninth. Okay, so sixth. Maybe last for today. Let's see. What time is it? Yeah. Okay. So it's AB square. A star B is AB square. So AB square is not equal to BA square. Therefore, not commutative. Then the next part. So we are considering A star B star C equal to A star BC square. That means A multiplied by BC square whole square. That's equal to A B square C to the power of 4. So A star B star C equal to AB squared star C. That's equal to AB squared C squared. So AB squared C to the power of 4 is not equal to AB squared C squared. Therefore, not associated. Understood?
Sir.
So 10th question was, find which of the operations given above has identity. That means in the 9th question, okay, so which of them has identity? So if you look at, for identity to have, right, there must be something. It's all on rational numbers, right? We are looking at all, these are all rational numbers. Okay. So in the rational numbers, you are actually subtracting something and you are getting second one or the first one. Definitely not possible with A minus B and with A square plus B square also. So I think we will do the 10th question, 10th round. Anyway, we don't want to rush. Okay. Actually, the answer is easy. Okay. But then we don't want to rush. That's a guaranteed. You can have a 1 mark question. 10, 11, 12, 13. We'll complete that in the next class. That's on Friday, right? And then what will you take next? We will go with the matrices and determinants, or you want to pick up physics next
Need
class?
to discuss my college already did.
We'll do matrices and determinants.
Yes, sir.
Okay, right. So we'll finish this and then we'll go to that. All right. So any major questions? Can't
No,
hear
sir.
you. No. Okay. So I think I am stopping the share. So I stop the share and then I am stopping the recording also. So stop.